Hey, welcome back. Today, our goal is to learn what a box plot is and the interquartile range. All right, so what is that? Let's jump right into it. A box plot. We use this when we want to plot data that is skewed. All right, so box plots are used with simple data sets, especially if the data is skewed. And to create a box plot, we need to figure out what the five number summary is. Now, maybe you've done this before, maybe you haven't, but the five number summary, we need to find the minimum value, the maximum value, the median, and then we have these quartiles in here, which are basically the median of the first half and the median of the second half. A quartile tells you the first quartile tells you the first 25% of data where that lies, and the third quartile tells you where the third 25% of data, or that'd be 75% of the data lies. So what we're going to do, go ahead and write these definitions down. Pause the video if you have to. The first quartile, as we said, sometimes called the lower quartile. It's the point at which 25% of the data occurs, like we said. The third or upper quartile is where 75% of the data occurs. We also then can figure out the interquartile range. The interquartile range is where the middle 50% of the data lies. All right, so here are the directions for making a box plot. I'm going to talk you through it and then come back up and see if we followed all the directions clearly enough. The first thing I want to do, we're going to be basically plotting the total number of points scored. I don't care about the games played right now. We're going to be looking at just the points scored. So what I would recommend doing is grabbing your graphing calculator. And so when you get your graphing calculator, if you hit the stat button and then enter, you will be given an opportunity to put the numbers into a list. Now, I've counted 13 numbers. One thing to know about these lists, see where in parentheses it says 14? That means that I'm on the 14th row. And so I'm in the 13th row here. It's just a good double check to make sure that you've gotten all the numbers in. And I have gotten all the numbers in. That is awesome. Now, one of the things we're going to show you how to do to make a box plot, we have to put the numbers in order. And if you notice, these are not in order. We have some numbers that are, greater than other numbers, and they're just kind of in a random order. So to put them in order here, I'm just going to quit out of the lists, and then see this subheading here where it says list. I'm going to go second, list, and if I go over to ops for the operations, the first choice is sort ascending. So I'm going to choose that and then choose L1 because that's where what? That's not what happened. See, sometimes that happens. So we're going to sort ascending, and then I'm going to choose L1 and then hit enter, and it just says done. All right, well, that's not very entertaining. But if I go back into my lists, I can see that they're now put in order. And that's important. So that's where I got these numbers right here. These are from the lists after I put them all in order. Now, to create a box plot, we first have to find the five number summary. We talked about that. The five number summary, the minimum, the maximum, those are easy. Okay, let's write those out. All right. And we also have to find the median. Now, we have 13 numbers here. I counted them. Trust me, there's 13. So if we have 13 total numbers, that means that, what do we have? 13 numbers. There's going to be one in the middle for the median, and then you'll have 6 on each side. So if I count 1, 2, 3, 4, 5, 6, and then the one in the middle, that will be our median right there. That's 470. So our goal here is to create a box plot. That's what we're doing. And we found 3 of the 5 numbers in the 5 number summary. We now have to find the first quartile. It's the point at which 25% of the data occurs. That's why it's quartile, just like quarter. I've heard that word before, right? So the first quarter, or the first 25%. Now, to find that, it's pretty simple. The median finds 50%. So we just need to find the median of the first half here. So there are 1, 2, 3, 4, 5, 6 different numbers to find the median. There is no number in the middle. It would come right here. So we add these up and divide by 2. Now, using our good old calculator, TI-84, make sure you use parentheses. You need to add them up and divide by 2. I get 298.5 is our first quartile. So 298.5. That is our first quartile. Then we need to find the third quartile. So I look at these 6 numbers over here. We don't include the median. 1, 2, 3, 4, 5, 6. And I want to find the third quartile comes between those two numbers. So I need to add those up and divide by 2. And as I said, make sure that you're using parentheses when you're adding up and dividing by 2. So our order of operations is correct. We get 1165.5. So now we have all 5 numbers in our 5-number summary. We have the minimum. That's one of the numbers we need. The first quartile. We have the median. The third quartile. Oops. Let's just do this. And then the maximum. And remember, those quartiles we had to figure out because they came between 2 numbers there. So those quartiles came right there. All right, so now let's go up and see how we actually construct a box plot now that we have our 5-number summary. Okay, we need to draw a number line. Got it. Add a scale that begins below the minimum and above the maximum. So our data probably should be represented from 0 up to 2,000. All right, so I'm going to put that on the number line. So as I spread out these numbers here, I'm going to put 0 all the way to the left. I'll put 2,000 to the right. And now, what some students do is they'll put these numbers on the number line. No, don't use and put the 5-number summary on the number line. What we want to do is we want to make our number line first. And so somewhere around here, it should be halfway between 0 and 2,000. I'm going to put 1,000. That looks pretty good. And then halfway here, we're going to put 500. And the same on the other side here. Uh-oh. Okay, so I have my numbers from 0 to 2,000. I put a scale on there. We have 1,000 here. I'm going to count by 500s. And then I'm going to plot the 5-number summary. Now, the way I do it is I just go and I put 5 vertical lines at the 5-number summary, each point there. So the first vertical line is at 135, and we have to estimate. All right, so that's 250. 135 is probably somewhere in there. So we put a line there. 298, that's pretty close to 300. I'm going to go with right about here. All right. The median's at 470. That's right before 500. So we got that right there. What else we got? 1165. This is going to be close. I got it. Remember, we're just trying to get it close here. And the maximum is 1999, which is basically 2,000. Now, you draw your 5 numbers from the 5-number summary. The minimum, the quartile, the median, third quartile, the maximum. And then the inner 3 make a nice little box here. So we're going to draw that over. We're going to draw this over. And then you extend from the side of the box out to your maximum. And that's how you make your box plot right there. Sometimes called a box and whisker plot. So as you notice, different parts of the box are different sizes, and that tells us different things. That's going to bring me back up here, the interquartile range. The interquartile range is basically the box part of the box plot. So I'm going to write that down right here. This is the box part. And what that tells us is where the middle 50% lies. Remember, we figured this all out. Each part of this is 25% of the data. So we divided the data up. We got 4 equal pieces of the data. So they're all equal. But notice how this whisker here is so much longer than this one over here. So what does that mean? That means that this data is spread out. It doesn't mean there are more numbers in here. It doesn't mean there are more players that have points that are up here. It means that the players that are here are spread out. Same thing for this part of the box. The players that are in here are spread out. Each part contains 25% of the total data. So you're going to start to get homework questions like how many points must be scored so that you're in the top 25%. Well, that would be between here and here. You'd have to use those numbers on the 5-number summary. Okay, now we started this whole thing by talking about using box plots when the data is skewed. You can easily see here where the skewness happens, which side. Here's the median, and then notice, so this is half the data right here. Half the box is on the left, half on the right, and if you notice on the right, it is spread out a lot more, so this would be skewed right. That's the shape of this graph. All right, so our next example, we're going to create a box plot using the 5-number summary. I already figured it out for you for the Chicago Bulls. All right, so here's where I want you to put that. This is a pause the video time. You're going to try it all by yourself. Here's the 5-number summary. I've already figured it out for you. Go ahead and plot it right here on the same number line right above this box plot. Go ahead, pause the video, and plot the Chicago Bulls from 1998, 97, 98. Plot their box plot on the same number line. Go. Okay, so here's what I got here. Starting at 167, if you notice, they're about the same. And then as you plot it, the median's a little bit lower. But if you notice that right-handed whisker really goes way out. And that's because of a guy named Michael Jordan, if you've ever heard of him. But if we're looking at the box plots, look at them here. All right, now, who scores more points on average? Which team has players that score more points? That's the reason why we're making box plots, so we can look at them and compare them to each other. Well, as I'm looking at it, I notice that Golden State Warriors have a higher median, which means in general their players score more than the Chicago Bulls did. I also noticed that both of the datas are skewed, so they have a couple players scoring a lot. They're skewed to the right. Okay, and we can compare maximum values here, third quartile. Okay, so you can obviously see right here that the Chicago Bulls is more skewed than the Golden State Warriors, but they're both kind of skewed to the right. Okay, so now what we're going to do is we're going to look at a stem and leaf plot and try to create a box plot from it. Now, to do this, we're going to use the help of our calculator, because I'm going to show you some things that your calculator will do. Why don't you take this data here and put it into your calculator? That's the first step. Pause the video and put this stem and leaf data into your calculator. Ready, set, go. Okay, so here's how I would put it in my calculator. I'm going to hit stat and then enter. And if you notice, I have the data from the first set over there. I'm going to move over and put this in L2 just so I don't have to delete the other data. So the first data here says that, what do we got? 1-0 is 10 inches. So 0.7 would be a 7. So I'm going to scroll down. I'm going to put in a 7, 7, 8, 9, 9, 9, all the way down. And as I finish putting the data in, I notice there are 16. When I put my data in here, look, I'm all the way down. This last row here is row 16. I can see that in the parentheses, so I'm just going to count these to make sure there are 16 points. That way I didn't forget any. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it looks like I got all of the data points. Now, what I want to do is make your life easier. So we're going to quit out of this wonderful area there. We go to the home screen. Now check this out. Here's a little, check this out. Check this out. If we go to stat, and you go to the right where it says calculate, we have this choice called one variable statistics. Now, these are one variable statistics because there's just one thing we're counting. In this particular stem and leaf plot, we're talking about bean going fishing, and these are the lengths of 15 fish. Earlier is the number of points scored. Okay, there's only one thing that we're counting. So we want to figure out the one variable statistics. When you hit enter, you come to this screen. Which list do we want? Well, currently we're working in list 2. So I'm just going to put list 2 there. All right. Frequency list. You don't have to worry about that right now. But then we go down to calculate and you hit enter. And if you notice, all this stuff starts shooting out on the screen. Now, some things you should know. Remember when we figured out the mean and the standard deviation before? Here is the mean right there. X bar. So where you have an X bar, that just means the mean. So this is a different way to get the mean. S of X, what do you think that is? Standard deviation. Yeah, Mr. Kelly played you. Like this way, it does everything. But I wanted you to kind of know your calculator. If you scroll down, you notice that it says n equals 16. That tells you how many data points. We just counted, so 16 is right. The minimum, the quartile, the median, the other quartile, and the maximum. It'll find the 5-number summary for you right there. OMG. So we're going to write this down. We're going to put this over here in the notes. We're going to come back to the calculator in a second, but let's make a box plot here. So to make the box plot, we need to draw a number line. And that number line has to start somewhere beneath the minimum value, which is 7. All right, so I'm just going to start mine at 0. And we need to go up. How far do we need to go? Up at least to 22. So how about if I put a 20 like right here? This is how I normally do my scale. And then halfway in the middle would be 10. That means this would be 5, this would be 15, and then I can put another one up here for 25. So let's put those numbers down. Okay, so zooming in here, getting our numbers all straight and nice and even here, we're looking at the 5-number summary. So these are the numbers we need to look at out of the calculator. So the minimum is at 7. So I'm going to approximate that is right about here. All right, and then the first quartile is at 9. Draw that line. 11. And as I said, I like to just draw the vertical lines and then I'll connect them later. 16. And lastly 22, which is about right here. Okay, so the inner 3 make the box and the outer 2 make the whiskers. So try to draw it nice and neat. And there is our box plot. Now, questions before we begin. Before we get into all these questions here, let's go back to the calculator. These numbers are great. I love them. They help us plot, and you're going to have to know how to plot it on paper, but you can also plot on the calculator. Let's go up here where it says stat plot. So we hit second and then the y equals, and you can see that our plots are all turned off. So what I'm going to do is hit enter, and right here I want to turn that plot on, so I hit enter again, and then I can go down to what type of plot do we want. Now there's two types of box plots. There's one that's called modified, and that will show you if you have outliers, and it'll show it with little points. But right now we're just going to do the regular box plot. We're going to hit enter, and then it asks you where is your data, your X list. That is where your data is. So mine was in L2, and I'm going to put it in there. Frequency we don't have to worry about changing. Color is blue. So now if you want to see your box plot, zoom 9. All right, zoom 9. If you notice right there, we can hit the trace button and it will tell us the 5-number summary. Okay, it'll go through the whole thing for us. Well, that's kind of fancy. Let's put that down here. All right, let's go back to the notes and we'll finish up. So find the interquartile range. Well, the interquartile range is the third quartile minus the first quartile. So this is quartile 3. Oops. Minus quartile 1, which in this case, we can go right over here to our 5-number summary. We can figure out that the IQR, or interquartile range, that's the IQR, is 7. So the IQR is 7. Between which two values is approximately 50% of the middle data contained? Well, remember, each part of this contains about 25%. So we have to keep that in mind. So between which two values, the middle, it'd be these two right here. That's our interquartile range. I'm just asking the same question in a different way. So between 16, maybe we should write this out as a sentence, huh? There, how's that? The middle 50% of the data is contained between 9 and 16. All right, find the range of the data. Remember the regular range, it's the maximum value minus the minimum value. So the range, all right, so the range equals the max minus the min, so that's 22 minus 7, so that is 15. What percentage of the fish were greater than 9 inches long? So I'm looking at my data here. This value right here is 9. So we're basically looking from here and up, the first quartile and up. And according to my box plot, that would be 25 and 25 and 25%. So that would be 75%, right? I mean, basically 75%, 9 inches or longer, so 75% of the fish. What percentage of the fish were greater than 7 but less than 16? So that's like greater than 7. Here is 7. So we want from here but less than 16. That is 25 and 25 and 25. That is another 75%. Okay, so now that we know these values, we can go through, we can look at the box plot, figure it all out. Remember, technology help. If you want to find the 5-number summary, you can just do one variable stats. So to do that, again, this is very important. I know you love this stuff. So you hit stat, and then you go to the right, and it says one variable stats. You got to put your list name. But x bar will be the mean, and s of x is standard deviation. Don't need to know that, but it's helpful. And then you make sure you scroll down for the 5-number summary. Okay, zoom 9 will fit the window to your data. So that's how you make a box plot. Again, the point is to be able to graph data that's skewed. We can tell when data is skewed with a box plot easily. So good luck on the master check. This is Kelly in K-Town. Remember, it's nice to be important. More important to be nice. See